welcome to Unit 4, Opener number 5, where we'll be solving a matrix equation for some unknown variables. Before we do that, it's worth taking just a quick moment to think about what does it mean for two matrices to be equal. Obviously, they have to have the same dimensions. In other words, they need to have the same number of rows and the same number of columns. And each element of one matrix has to be equal to the corresponding element of the other matrix. So we'll use that fact as we go through this problem. For starters, we're going to have to multiply these two matrices over here on the left-hand side. And if you're having trouble with your matrix multiplication, you want to check out Unit 4 Opener number 3. But for now, we're going to multiply 4 times 9 and get 36. And we're going to multiply 5 times negative 3 and get negative 15. In the top left spot of this matrix. Next, I'm going to do the 4 times the negative 1, which is negative 4, and then the 5 times the 8, which is 40. And then I'm going to do 0 times 9, which is 0, plus 8 times negative 3, which is negative 24. And finally, I'm going to do the 0 times negative 1, which is 0, and the 8 times 8, which is 64. Alright, so we do our little bit of simplifying here, and then we'll rewrite our matrix equation in just a moment. So that matrix ends up being, let's see here, 36 minus 15 is 21. And this is negative 24, and this is 36, and this is 64. Alright, and that equals this matrix. 2x minus 1, z plus 2, absolute value of z plus 2, y over 6, and 8 times w minus 2. Alright, so as we said just a second ago, in order for these two matrices to be equal, what that means is that each element in the first must be equal to its corresponding element in the second. So 21 is going to be equal to 2x minus 1, and negative 24 is going to be equal to the absolute value of z plus 2, and 36 is going to be equal to y over 6. I think you get the picture. 64 is going to be equal to 8 times w minus 2. So essentially, you have 4 separate equations that you're going to solve one at a time. Maybe we will name them A, B, C, and D. And they match up over here with A, B, C, and D. And we're just going to set A equal to A, B equal to B, C equal to C, D equal to D. We're going to solve 4 equations in order to find the values of x, y, z, and w. Alright, so I will start with equation A. 21 equals 2x minus 1. Add 1 to both sides. 22 equals 2x. Divide both sides by 2, and you end up with 11 equaling x. Let's solve equation B. 36 is equal to y divided by 6, so I'll just multiply both sides by 6. And I'm going to cheat and use the calculator. 36 times 6 is 216 for y. Now equation C looks interesting. Negative 24 is equal to the absolute value of z plus 2. Now, fortunately, that's not possible. So there is no solution for z, right? We can't have the absolute value of something being equal to a negative number. So there is no solution for z. That's interesting. And I guess you could solve equation D, but I think at this point we've done sort of the important doing. 64 equals 8 times W minus 2. And then to solve this equation, you could distribute out that 8, but instead I'm going to divide both sides by 8 and get that 8 equals W minus 2. And I'll add 2 to both sides and get 10 for W. Now, we have solved for 3 of the 4 variables to make this original matrix equation true, although unfortunately we can't, this entire matrix equation can't possibly be true based on this piece right here. It's impossible for the absolute value of z plus 2 to be equal to negative 24. But in any case, this is the general idea of how you solve matrix equations. You do whatever sort of simplifying may be necessary. In this case, we multiply the 2 matrices. But then you essentially just set each element equal to the corresponding element in the other matrix. You set them equal to each other, and you solve for whatever it is you needed to solve for.